Hello everybody, welcome back. Today I want to look at the second method for using prime factorization to find the GCF. So in the first method we looked at listing factors. Now this is okay when the numbers aren't too large, but another method we can use is prime factorization. So what I did was I did the prime factorization of 138, and it was 2 times 3 times 23. And then I did the prime factorization of 198, which is 2 times 3 times 3 times 11. And any common factors is going to be your GCF. So your GCF is going to equal is going to equal 2 times 3, which is equal to 6, like we found in the above. Okay, so that's just another method that can be used for, like I mentioned, finding the GCF using common prime factors from your prime factorization or your list of prime factors. Okay, you can try that using the check your understanding. All right, and then the next one I wanted to look at was example 3 was the LCM. Okay, so LCM, we looked at the first method was just listing the factors. So method 1 we called method 1 just listing the factors, right? Or sorry, listing the multiples. I apologize. Listing the multiples. I apologize. So until we found a common multiple. So this can it can be a little tedious. It works when a list doesn't get too long. But another method is using prime factorization. And again, this is a great method as well. So when you use prime factorization as a method, what you do is, again, you list the prime factors. So I list the prime factors of 18, 2, 3, 3, which is also be listed as 2 multiplied by 3 squared. 20, which is 2 times 2 times 5, which, again, can be listed as 2 squared times 5, and then 30 equal to 2 times 3 times 5. All right, so, and then you can list these together, and the ones that you're going to list together are going to be any factor that has the greatest exponent in any list. So here we had a 2, a 3, and a 5 as a factor. All right. Now again, you can take more than one from a list, but you always take the greatest exponent of that. So here we had a 2, and a 2 squared, so we take the 2 squared. We had a 3 squared, and we just had a 3, so we take the highest exponent, which is 3. And then we had a 5 in this list or this list. So you could have taken it from here or here, but the greatest exponent is 5. Which would equal 4 times 9 times 5, which is 180 as well. Okay? So again, the greatest power in any list of each possible factor. So we had possible factors of 2, 3, and 5, and you take the greatest power in any list. So for example, if this one had also had a times 7 in here, you would also have to take the 7. So it's not just because there's 3 lists, there's 3 factors. That's not the case. You take the greatest power in any list of each possible factor. Again, so you could have 10 numbers here if you had 10 different prime factors. All right, so just be mindful of that when you're working on those questions. Okay. So that's it for this video. It's just I wanted to add to a previous video just to make sure that was clear. Okay. So like I said, when you're listing them, doing the LCM using prime factorization, it's the greatest power in any list of each factor. Thanks for watching, folks, and you can give that a try and check your understanding there as well. Thank you.